I don't remember how you would do the math before.
That sucks.
Well, we'll get to it.
This is true.
It's just like I got to the word problems in the homework, and I don't remember how to do them.
That happens. All right, guys. So let's see. Let's look at these. Oh, there was. All right. If there's anybody who is here right now who is not here yesterday, there's one person that told me. Did you make it today? Shing, I think is the last name. Has not made it back yet. Okay. All right. So let's look at these one at a time. Number one. So thankfully, I didn't have too many people. Yes, sir.
6x plus 3.
6x plus 3. Oh, okay. Thanks. I use somebody else's. There we go. I didn't have too many people that tried to cancel something out here. Why can you not do that? Or can you do that? Maybe I'm wrong. Can you cancel an X out here?
No.
Yay. Why not?
It's added to property.
Say one more time.
It's not being multiplied.
Beautiful. And why would it have to be multiplied?
Because if they're being added together, you can't.
Why not? What's this?
It's a
Division.
That's division. And division only cancels out multiplication. Beautiful. Division can't do a damn thing to addition and subtraction.
Yeah.
Right? Otherwise, you'd be able to reduce. Can you reduce 4/5? Even though it's 4 over 4 plus 1? Of course you can't. You can't cancel that 4 out. Division can't touch that addition, right? Okay, so I only had a couple people try to do something there, and that made the whole thing really freaky. All right? So don't do that, because that does tend to make things freaky when you do illegal things. What's the right way to look at this?
Find a common denominator.
Yeah, and to find the common denominator, I have to know what all the parts are from the bottom. So I know this dude's got an X. I know this dude's got an X minus 1. That guy's got a what? Now this is the next level where people may make some mistakes. How do you factor this?
Take X out as common X.
Yeah, GCF. How do I know? I can't factor it like this. It's not a squares, it's not a cubes, it's not 3 terms, it's not going to factor like this. There's no way. And what do you always try first anyway?
GCF.
GCF. So of course what comes out?
X.
Incredibly, right? The problem on these normally gives you hints. Right? The bottoms on the other dudes normally, not always, not really in real life, but here just to get the idea, normally this is made up of these. Right? The next thing to be careful about is, if I want that to be an X minus 1, let me just put a minus 1. Yay! Can you do that? What's the only thing you can do to the top and bottom of a fraction? Multiply or divide. Right? And division really is just multiplication flipped. Right? There is no division. Just to freak you out. There's only multiplication. But, so I can't just subtract 1. Otherwise, 1/2 would equal 0 over 1. That's neat. Right? You owe me $500,000. Well, I owe you 0. No, math. Don't try to do that. Right? Get your thumbs broken that way. So the right way to look at it, the better way to kind of do this, there's 2 ways to do this. You could multiply everything by the LCD, which I used to teach you that way, but I think what's a little bit easier to see is give everybody what they're missing. So of course he's missing what? He's missing X. And the minute you have all the bottoms the same, you multiply both sides by it, so they all go away. But what are you left with?
3X.
Yeah, you get 3x minus 1 plus 4x. That looks really kick-ass cool, right? So normally when you have ugly stuff in the bottoms, you're going to multiply eventually to kill it. And why are you allowed to do that here? Are you always allowed to kill the bottoms of fractions? Wouldn't that be great if you could? It's too bad you can't. But here I can because...
They're all the same.
No.
You can do whatever the top to the bottom.
No. Yes. There we go. It's an equation. There's 2 sides. I can do something to one side and the other side there's a balance, right? If I give you a problem, 3 over x plus 2 over x minus 1, you can't multiply by the LCD and kill it. No. There's no other side to balance you. You can't get rid of the bottoms. You with me? Okay, good, good, good. Because normally when students first learn they can kill fractions, you get a little overly optimistic, right? There's a fraction killer. No, but you need two sides. And then this should be easy. The next kind of level of problem I had was this. And I'm not thinking that you believe this. I'm thinking that you were just, there's other math you were worried about. But obviously this should be, minus 3. Right? Add 3, that you get 7x equals x plus 6. Subtract the x, you get 6x equals 6. You get x equals 1 now. I think 2 people told me the right answer. This is not the right answer. Why can this definitely not be the right answer?
The denominator.
Everybody knows, follow the arrow, right? It makes this bottom 0. You can't have that. So, what's the answer then? The only possible answer freaks it out, so there is no solution. Beautiful. How are we doing? So, anytime you start with fractions with variables on the bottom, you have to check your answer to make sure that it didn't make the original equations go crazy. Now, real quick, since I didn't have all of you guys, I had a few of you guys from my 110. So my 110 people have heard this before. That's kind of evil. Why does math do that? Math says x is 1. No, it is not. So why does math do that? Why? What the hell, man? Math, you're hard enough already. What the hell is this shit?
It doesn't care.
Yeah, it doesn't care. But why is it not math's fault? What did we do from this step to this step?
Started with the wrong equation.
We multiplied by this. Now that we know x has to be 1 to make it true, what would this be?
0.
0. So can you multiply both sides by 0?
No.
So math is being really nice to us. It's saying, you didn't know it was 0 then, but I'm going to tell you it was, so you know there's no solution. You didn't know you were multiplying by 0, person. It was your fault, really, but I'm going to be nice to you. So it's not math's fault. No solution. Okay. You're a math teacher. Of course you're going to defend math, but it's just the truth. It's not math's fault. All right, so that's problem number 1. That took forever. Let's see. Problem B. The other 2 were inequalities. So somebody help me out here. Some people made little simple mistakes again with the distribution. Is there a foiling problem up here?
No.
So on a few of you guys, you drew in parentheses here, which made it a completely different problem. So on a couple papers I wrote, why did you solve a different problem? Right? What's the only thing I have to distribute here? Yeah, this is 2x, and then minus 3 gets put through. That's the only thing multiplied. So then I get 2x minus 3 minus 6x, right? Yeah, negative plus. That's a really easy mistake to make. But just to let you know, if people who have me before know this, I grade on concept. I don't take off nearly as many points for little brain farts like that. Unless it seems to me you actually believe that you don't have to bring a negative in with it. If you do it all over the damn place, it's a problem. But here, I wouldn't take off a ton of points if you made that mistake and put a minus there, as long as you did the rest of the problem fine. All right? So now this is 8x, add the 3, divide by 8. Cool.
Now you just got to write an interval notation.
Exactly. Interval notation and graph it. I heard the beginning of a question. So if I do graphing, here's 7/8. Good. Don't put open circle. We're not doing circles anymore. Circles crap. Open circle, no. Parenthesis, yes. Right? Parenthesis, half of an open circle. So you have half the work to do. So you make the circle. It's going to open this way because I want to shade the way that's pointing. Right? If the variable's on this side, I shade in the direction that's pointing. I don't know if you guys ever heard that. Now, how do I take that to interval notation?
Negative infinity, almost 7/8.
By the way, if we hit something up here that doesn't make sense to you, please, dear God, ask now, right? Don't just sit there and let him do his thing. This is, part of the whole thing. Yes?
So then why are we doing the parentheses?
Say again?
Instead of the circle, why are we doing the parentheses?
Because that more directly relates to interval notation.
Okay.
Yeah. So now, to make this interval notation, I actually just take the same symbol on my 7/8. So I go up to 7/8 from negative infinity Up to 7/8.
Okay.
I like it.
Do you do the same thing with the bracket?
Yeah, the bracket would be if this would have been less than or equal to.
No, I mean, if it is less than or equal to, do you also put a bracket?
Yeah, put a bracket, exactly. Good.
You're
And the
saying-
bracket is, so parentheses like an open circle don't include. A bracket is like part of the letter I for include. See that magic? Right? Just to help you remember, if you don't already have a way to remember. So that's that for that problem. Part C, we're going to see the brackets come into play. Oh yeah, so part C was exciting. Let's see.
Just so you know, that's actually not being videotaped because you can't see it.
You have to push it like up to the sky.
That's weird. What's way up there? Where are you? Oh, it's way up.
It's way up there. I was gonna say something about
There it is. All right. Yay. Yeah, I need to. Well, I don't want to make you guys feel too.
Okay, pull it back.
Thank you. Let me change all my angles.
supposed to be forward.
Now it's perfect.
Now you can see everything.
Thank you. So feel free, anybody in the front row, you're in the equivalent of a splash zone, but you're in the, please dear God let me know if something weird's going on in the camera. Alright? I can't see it. If somebody calls me and freaks it all out, if I forget to put it in airplane mode so nobody can call me. The first step, I saw a lot of people just kind of do this and go for it. And then my concern there is absolute values then don't mean a damn thing. Right? They're just symbols that math people made up that we just put around stuff that don't mean anything. But of course, what do absolute values mean? What do they refer to? Distance, which is why how far from zero or how far from something else is. So the way I teach this is this tells me the distance between these two things has to be greater than something. So I want you to stay the hell away from me. I call this a restraining order problem. Right? You must be at least 22 feet away from me. Stay away from me, you freak. You with me? If it was less than, it's stay close to me, dear God. You're going into the haunted mansion with the monsters and stuff. Stay close to me. So I can see that's going to be a sandwich. If it's less than, it's going to be like this. It's going to be two separate sets if it's greater than. Stay away from me. Either over there or over there. Okay. So I know what to expect. So here it's got to be an or. There's always two cases with absolute values. So what's the other way for this to happen?
3x plus 8.
Yeah. 3x plus 8 is less than or equal to negative 22. Give me a number that's less than or equal to negative 22. I was waiting for you to say negative 22. Negative 23 is less than or equal to negative 22, right? And what's the absolute value of negative 23? 23. And that's greater than or equal to 22, right? So he could either be just straight up bigger than freaking 22, and of course this will be true, or this could be less than or equal to negative 22. And then the absolute value makes this true still. You guys with me? That's why those are the two cases. I had way too many people doing this for the second case. What did that person do? They changed the sign. So one thing is, it sort of doesn't make sense because you made it negative in a way. But the absolute value can't affect part of a number. It's got to affect the whole number. So if you did this, you were completely fine. I love it. The absolute value either leaves it alone, or it totally changes the sign. Now see how these are equivalent?
Once you divide by the negative.
Divide by negative, the sign flips. That's why one case is leave everything alone. The other case is change the sign, flip the sign. That's why. Yes, sir?
Do you always flip that inequality?
Always.
Okay.
Definitely. Because it's equivalent to dividing by that negative that you get. That sign's going to automatically flip.
Okay.
And now you got two relatively simple problems right here. You get x greater equal to 14/3. Here you get x less than equal to negative 10. So then you get those two separate things. Stay the hell away from them. Right? Stay the hell away. So you get the negative 10 less than. What symbol's going to go on it?
Bracket.
Bracket. So if you want to put a closed circle, put a bracket instead. Right? Some of you guys are like, well, what's going to happen in the next class? We're going to make it stars. No. This is it. This is the official thing. And then 14/3 is plotted up there. And also on it goes bracket. And the interval notation should be relatively simple. But be real careful. Don't do this. A few of you guys were doing that. If you find infinity, you've nirvana, you're like on another plane. You've just done powder, become pure energy. Anybody ever seen that movie? Powder? No? Look it up.
Yeah.
You'd be amazed who actually was the actor doing it. So don't put infinity on there. You're saying you found infinity, which is neat. Come to me if you've done that. Win an award based on what you did. So this goes from negative infinity up to negative 10. Or 14/3 up to infinity. Okay, everybody should have seen those symbols before. If you haven't, now you have. Yes?
So I put mine in one equation, like when negative 20.
Oh, yeah, good. So you had this. You had, let me try to remember. You had like 14/3 less than or equal x, less than or equal to negative 10, something like that?
Well, I got the same answer as you did.
But no. This is not the same answer. This. What is this claiming? This is claiming that 14/3 is less than negative 10. You can't put this in a single phrase because it's two separate things.
Okay.
Does that make sense? Cool. Okay. So be really careful. You can only do this closed dude if this was a less than.
You can put it in one if it's less.
One thing if it's less than. Because what does less than mean? It means stay close. I want your distance to be less than 10 away from me. So stay close to me because there's a monster out there. I want you to be close to me. Right? I watch way too many horror movies. Right? They're all out there looking for the werewolf.
I think of Pitch Black.
Huh?
Think of Pitch Black.
Oh, pitch black?
Stay in the light.
Yeah, exactly. Keep that light on. Weird, freaky Vin Diesel on your glowy eyes. Alright. Some of you guys are like, I don't watch this kind of movies. I have no idea what you people are talking about. So, real quick, if it would have been this, from the very beginning, you could have written that as one line. The two cases would be, I want either this is less than or equal to 4 already, or it's bigger than or equal to negative 4. So that's the whole idea of stay close to me. I don't want you to get any more than 4 away from me. So you can either go 4 up or 4 down. Don't get any further away from me than that. Does that make sense? Mm-hmm. So
we do it on the graph?
Yeah, well here, then you solve it real quick. Add 2, get x by itself, right? And then the graph would be negative 2 to 6 with what symbols? Brackets. Because it's allowed to equal, right? And then the interval notation is stupid easy. Should be. I feel completely safe saying that. Because it's bracket, that number, bracket. It comes right off of the graph then. Okay, maybe. Okay. All right, that's number 1. Number 2. Some of you guys had a vague idea of what this meant, right? It'd be nice if we could buy shoes that actually stay tight. The bottom of a fractional power is the root, because what's on the bottom of plants? Roots. I don't want to hear any botanists tell me about potatoes and crap. Most plants, the roots are on the bottom, right? Well, a tuber... No, shut up. So the root is the... the third root of 64. You could put the square inside, but don't be silly. Doesn't really matter. Is everybody cool with that? Or does somebody say, why the hell's that? Okay, good. All right, I'll make this quicker. Everybody just accepts that based on what I said. I like it. I can't let that light. So, 64 squared to the 1/3. What do you do with those powers? Multiply them. So that's this, right? That's this. That would have a square inside. Why does that suck? Because 64 squared is huge, and this is the kind of problem I want you to do without a calculator. So there will be sometimes some quizzes or tests that I will not let you use a calculator on. So just to let you know now, if you are way too reliant on a calculator, you need to work on not being so. Right? But I could also put this. That still multiplies me 2/3, right? Put down the squares on the outside. Cube root of 64 is 4. Right? It's kind of an evil number because square root of 64 is 8. But the cube root is 4, and then squared is 16. Cool. So a few of you guys got there by doing the cube root of 4096 or whatever the hell it was. And I'm like, damn, if you did that in your head, kudos to you. But I doubt it. And then 2b, I was a little bummed that how many mistakes there were on this guy here. By the way, what's the order operations? Yeah, what's the saying? Please excuse my dumbass son. Or dear Aunt Sally. Sorry. All right, sometimes I have people with actual sons and like, okay, I can remember that. But the problem, of course, real quick, a little thing about this. This is stupid. You don't write it like that. That makes it look like multiplication is before division, which is not true. It could have been this. How do you say that? Right? So they said, oh, that's easier to say. We'll do it that way. But it's much better if you do this and you just say, okay, definitely this, and then definitely this, and then either one of these as it comes, and then either one of these as it comes. Right? So if you write it in one big line, everybody thinks multiplication before division. That's not true. You do whichever one of those comes first. So in this case, I got multiplication and I have exponents. So of course I do exponents first. Negative 2 cubed.
Negative 8.
I had way too many x to the 5th powers here. Little tear escaped, but I soaked it back up because I realized it was an evil first day kind of thing. I have 3 groups of 2. That's the definition of multiplication, isn't it? So you have desperately got to start trying to figure out why things make sense, because they have to make sense in math. That's the basis of math. Everything has to make sense or we have to throw it out. So you don't just go, I'll just sometimes multiply and sometimes add. What the hell? Why does it make sense that you do so? If I have this, why does it make sense you add?
Because you're adding your...
Yeah, one way to think about it is you got 2 x's linked. You're going to link 3 more x's on, so of course now you have 5 x's, right? So that's kind of like silly. That totally is, you add the exponents. And why here does it make sense you multiply? Well, it's based off of what we just said. 3 groups of x squared, so x squared times x squared times x squared, 2, 4, 6. That's the definition of freaking multiplication, isn't it? Mm-hmm. 3 groups of 2. You got 3 groups of 2 apples, Johnny. Okay. You got 6 apples. Sorry. Oh, wow, it's just so easy. But that's, so many of us don't take the second and just think, just for a second, why does that make sense? And then you won't forget it. I don't have it memorized, I just know why it makes sense. So here I get 6. 3. So a lot of you guys get 3 there and then 5 there. It makes no sense. 1 plus 3 is 4 if you want to add those. But you have to multiply them, yeah. And then, of course, now you just 3 times negative 8. X to the
7.
Good. One of them, 6 more is 7. 2 of them, 3 more is 5. Cool. All right. Okay. Oh yeah, part C just looks... That's what I think a few of you guys just looked at and went, no, I'll do the next one. For part C, the first... I'll tell you what I recommend, and there are other ways to do this.
X third, y negative 8, C negative 4.
So what I recommend is to simplify the inside. That actually goes along with order operations. Order operations would say, do in here first, inside parentheses first, right, and so forth. But you could bring the negative 3 through, and I'll show you why you don't want to do that, because I'd rather reduce this at least. Have smaller things to raise to a 3rd power, right? And if I collect these together, I got less stuff to raise to a 3rd power. Sounds good. Okay, maybe.
Bless you.
Bless you. So here I get,
2 and 5.
so there's a few people putting a 3 out there. The 3 cancels, right? It's gone. It's dead. Now here, this gets weird. I had some people telling me this is x to the negative 9 or something. But what does a negative power mean?
Has to go to the bottom.
Flip it. So I got 3 down here already, 12 more coming, 15 on the bottom. Now on one level, some of you guys might think that doesn't sound mathematical, but that's exactly what math is. Math is just a way of representing an idea. And an idea can be expressed to yourself any damn way it makes sense. So that is completely math. 3 there, 12 more coming, I got 15. Yay. 3 there, got 8 more coming. 11. You guys kind of with me? Mm-hmm. The other more direct way to do this, the more mathematical way, is when you divide, what do you do with powers? Subtract. Negative 12 minus 3 is negative 15. That would flip down. That takes 2 steps. Screw that. Mm-hmm. Here, the 5 comes down, and there's just 1 there, right? You can say 5 comes down, 4 goes up. So you could do, if you want to do it in 2 steps. And then, of course, how many z's cancel?
4.
How many's left?
1.
Where? On the bottom. Like. All right. You guys doing all right? I don't prefer this either, by the way. I don't prefer just talking at you. But this, you did this yesterday, so I'm just going to talk at you about. And then this thing I look at as having 2 commands. The 2 commands are flip it and then cube it. So don't try to do it all at once. It's crazy. So flip it. So I flipped it. Negative's gone because it's done its job. And now I just have to cube it. 5 cubed is 125. What do I do with the powers? 45. Good. Multiply. 2 cubed. And 11 times 3, 33. Cool. Does this seem familiar? It's coming back. Okay.
I don't like the breaks.
What's that?
I don't like the breaks.
The breaks?
Yeah,
Summer break.
Summer break.
Oh yeah. Okay. I like them.
I don't personally.
But you're right. Math leaks out the brain. All right, there we go. Oh, now we're to the factor. Oh, I forgot. I got to remember, I've got my 110 people have this, but I have a factoring sheet, a little reference guide for if you have 4 terms, how do you factor it? If you have 3 terms, how do you factor it? If you have 2 terms, how do you factor it? Right?
I think I lost that already.
I got it.
There you go. So I'll put it up on the website if I remember, if somebody reminds me. So you guys can have it if you want to. Because apparently a lot of us have forgotten how to factor. And factoring is one of the most important damn things there is. Anybody going on to 178 or 180 after this? Calculus or business calculus? The reason people die, especially in 178, is because they forgot how to factor. And factoring is stupid huge important in calculus. It's how you find where neat things happen on a function. You have to factor something. So I can't stress enough how important it is to remember how the hell to factor. I have way too many people trying to write this as something squared. But then you're going to have to get 3 terms. You have to get 3 terms. The only way that you can get 2 terms is if the middle terms cancel. And the only way the middle terms can cancel is if they have opposite signs. Yeah, so this is a difference of squares. Right? There's no GCF. He's got no A's, he's got no X's. That's made of 2's, that's made of 3's. There's no GCF there, right? So just start to attack it. Cut everything in half, and you get 4x minus 9a squared. So you just cut it in half. And then the other guy's got to do the same damn thing with a plus. Right? So difference of squares is what I call a thank God problem. Or a thank fill in your favorite deity problem. Right? Because I don't care how much stuff I put in it. If everything can be cut in half, you do it. And you put a minus and a plus. And you're done. That's a thank God problem to me. Now, can I go one more step?
No.
Careful, no. Everything here is a square except this dude. So I'm done. If I would have made that a 4th power, this would have been a squared. I could have taken this one further, right? Mm-hmm. This one, can I go further if it would have been a square?
No.
So sum of squares, you can't factor those.
Well, you can.
You can with complex numbers, but we're not going there yet. Yeah.
So do you have to go until your first term is a single, like has no exponent?
Until you can't factor anymore, which is, in a sense, not a satisfactory answer, but it's the truth. I mean, it's in this case, if I would have made that a fourth power, this would have been a square, this would have been difference of squares. If I would have made this a sixth power, this would have been a third power, this would have been nothing. I still couldn't go further, right? So I don't want to say, yeah, take it till you get a first power. That's not true. Take it until you can't factor it anymore. Okay, cool. That's done there. B is this dude. Now, a lot of you guys try to, not a lot, but enough, try to attack this directly. This is currently in no form at all, right? 3 is not a cube or a square. It's 3. You can't break it up into nice numbers, right? So what do you always try first to save your S? GCF. So what comes out of the numbers? 3. And an X comes out.
X cubed minus 27.
Kick ass. And a lot of you guys got there and stopped. That's way too optimistic. What did you uncover? GCF, sometimes it's the only thing you do, or to uncover something else. This dude is a cubes, which is normally the most hated of all factoring types, right? But let me see if I can convert some of you guys. Real quick, side note. Don't write this down or anything. This is really easy. How do you factor that? Yeah, why is that so damn easy? Because there's only 2 of everything. So if I put 1x there, there's only 1 other x to put there. If I put 1 3 there, there's only 1 other 3 to put there, right? Because it's just 2 of everything. And then minus plus to make the cancel of the stuff that I don't want. You guys kind of with me? Cube's exactly the same damn thing, believe it or not. With one little weird dude in it. But let's see if we can make this make sense. How many of each thing do I have now? 3. X cubed is XXX. 27 is 333. Alright, so the little dude is a little dude. You can only put one thing in the little dude, right? So you have a little dude, and you have a big dude, right? So in the little dude goes 1x minus 1 3. So it's always the same sign. So how many x's have to go here? 2, x squared. So that overall I get x cubed. What has to go at the end? 9. Because that's how I get minus 27, right? So why don't I stop there? What the hell's up with you math people putting extra crap in place? Because I get a minus 3x squared. Do I want a minus 3x squared? No. And I get a plus 9x. Do I want a plus 9x? No. So the cancellation term, the term that kills those extra crap you don't want, is the product of these two, opposite sign to make it cancel, right? So I got a 9x, but now I get a minus 9x, don't I? I got a 3x squared, but now I get a negative 3x squared. Now I get a positive 3x squared. That cancels, doesn't it? So there's a lot of little sayings. Some people don't like the way I teach sometimes because I don't buy into a lot of little sayings to remember stuff because they make us not look to see why it makes sense. If we see why it makes sense, we are much more likely to remember it and build on it for future math. So if you know soap, that's fine. There's nothing really wrong with it, but make sure you understand why it makes sense. If you don't know soap, same sign, opposite sign, always positive. S, same, opposite O, always positive AP, soap. It's a nifty little mnemonic. That one I'm not too angry about. I can deal with that one. But if you build all your math on little sayings and songs, you don't really necessarily understand why they make sense. You just remember, I do this when I do that, yeah, and then you don't know why you're doing that. I don't know if you guys understand what I'm trying to say. If you had a teacher that told you a lot of little songs and little stuff, and it was all, everybody went, no. I don't know how well you really understood what you were doing. Okay. And then our other favorite one. are these kind where the first number is not a 1. Now, I don't think I saw... There's a certain method, your teacher might not have called it this, but there's a certain method of factoring called bottoms up. It sounds very different from math, but has anybody ever heard of that method? They might not call it that anymore. I don't think I saw it on anybody's paper, which is good, because they don't allow it. Unless you explain to me. Write a little paragraph as to why it works. I haven't had anybody take me up on that yet. But when you have a number out front that's not 1, normally the thing you do, you could either do trial and error. So 4 could be 2x and 2x, and then 10 could be 5 and 2, and then you see if that works. It doesn't work, so then you try it again. So trial and error is a valid method. I wouldn't necessarily go straight there, especially if you're not as good playing around with numbers. The more direct way to do this is you multiply these two. And then you do exactly the same thing you always do. Find factors of that number that make this number when you add them. Right? So, of course, what would those be?
8 and 5.
Yes. And which one's negative?
8.
8 to make that negative. Now, the bottoms up method would say, now divide both of these by 10 and do some magic. So if anybody wants to try it that way, don't do that. I won't accept it. You can go cry to your last teacher. I don't care. Right? Unless you can write me a little paragraph about why it works. So it seems like nobody here uses that. I didn't see that anywhere, which is good. Because the next step after this is easy. It's really easy. You don't have to rely on magic. Just freaking break the middle term up. Minus 8x plus 5x minus 10. So that is this. So these are the same stupid things, right? So I just did nothing. Yay, Jeff. Good job. But what I did is I made this 4 terms instead of 3, so now I can use grouping. Now, how many ways is there to break this? I could have made this negative 2x and negative 1x, right? Isn't that negative 3?
Yeah.
But the grouping wouldn't work. The grouping will only work with those numbers. So I could have put the 5x first and the negative 8x second. That doesn't matter. Grouping doesn't care. So real quick, grouping. What comes out of these two? 4x. 4x. 2. 5. So then you get 4x plus 5x minus 2. So if you do trial and error, it's fine. If trial and error kind of drives you crazy because you can never get there quickly enough, do it this way. Look, that wasn't that crazy long. Yes, sir. Yes, sir.
I was taught a method called X factor plus, where you do the first thing, but you said...
Oh, yeah, if for some reason this helps you, right?
Then, like, there's another part where you take the 4 and you find the fact, like, so it cancels out, so it ended up being x and negative 2 because the 4x. I have to show you, but...
You'd have to show me. It sounds like that might be the method I was talking about,
yeah,
that I won't accept.
But I didn't, it wasn't with the negative 10, but yeah.
Oh, it wasn't with it, okay. So maybe it's some variation on that. Okay. All right. Number 4. Some of you guys realize there's a shortcut on number 4, which is awesome. There's not a damn thing wrong with it. The more you know, the less you should have to do. Before, I had a rectangular parcel of land. Way too many people will tell me that's 13. We're opposite corners. There's one corner, the opposite corner is there. That's 13 feet. And then the length is 7 more than the width. So if you call this x, this will be 7 more than that. And of course, what governs the relationship between those 3 things? Pythagorean theorem. It's a triangle you just created. And I know it's a right triangle because it was a rectangle to start with, so there's a right angle there. So the a squared plus b squared equals c squared has to hold, has to be true. So you get x squared plus x plus 7 squared must be 13 squared. Now what happens with this is your brain kind of says, we got enough work to do. We must not have to FOIL this. There's enough, so I get a lot of people telling me that this is, which is wrong, right? X plus 7 squared, you got to FOIL it. So the middle term is 14x. All right, let me just stop there for a second. You guys all kind of with me? If I'm going too fast, please, dear God, slow me down. Because if nobody does that, I tend to accelerate. Right? So some people got here, and I don't know if you just ran out of time or you weren't sure where to go from here. but you put your like terms together, you subtract the 169 over, and then I could, do I have to do it this way? No, because I can divide by 2. And then I can just do it the easy way, right? I can divide by 2 because I have 2 sides. It's an equation, so I can divide the 2 away. And then you just got to figure out how does that factor. And 12 and 5, and of course, which was positive?
The 12.
Bigger dude, yep. So we get x is negative 12 feet, which is neat, right? So please, dear God, nobody told me the answer was negative, I don't think. It always scares me a little bit. Or, that's really, I want to come to your house and see what you built that's negative 12 feet by something. Some weird black hole material. It's like in you. Here. So x is negative 12, no, or x is 5, sure. So this is 5, and this is 12. If you just put that, I'm going to be a complete dork like I was. I'm going to say, light years, miles, bananas. So you got to tell me, that's what? That's feet. Okay. Yes, ma'am.
When I'm trying to sum stuff, I get confused of how you took the 169 over to the other side and set it to 0. I get confused if I'm supposed to set it to 0 or move to the other side.
Awesome. I'm so happy you asked that question. What was here that told me I had to get it equal to 0? What's the part of this equation that told me I had to get it equal to 0? The square. If it was linear, if those weren't there, if those canceled, I could just get x by itself, right?
Okay.
So then I would subtract 49, divide by 14, right? Like I would normally. This requires me to do it a different way, because I can't get my x's together in one place. So I can't do it the way we did before. So if you ever have a higher power than 1, you might have to set it equal to 0 and factor. Right? That's our way around it. So when we factor, we create 2 little linear equations that we can then solve. Right? So that's the trade-off. 1 ugly equation or 2 easy equations. We're like, we'll take the 2 easy. Cool. Okay. Okay. Starting to bore myself doing so much. This is 5a. So you guys must be suffering here, sir. Anytime I say find the domain, if I don't say anything else, I mean it's got to involve real numbers. The output's got to be real. The inputs have to be real. Some of the real number, because we're only graphing real numbers for the most part. I'll have to be very specific if I want to include complex numbers, right? So find a domain means what x inputs am I allowed to use that make this come out to be real? So anytime I ask you for the domain of a function, say in English what the restriction is. So in a square root, what can't happen?
0.
0 can happen. What's the square root of 0?
Less than 0.
Square root of 0 is 0. Because 0 times 0 is 0. So that's cool, but it can't be negative. So it must be positive or 0. So how do you say that mathematically? So the inside, so here's the English. You see.
3.
Inside must be positive or 0. So let's make that a little bit better in English. Must be greater than or equal to
0.
0. Now I can take it to mathish, right? From English, go to mathish. Inside.
3x minus
3x minus 8. So the inside, whatever that number is,
greater than or equal to 0.
greater than or equal to 0. It must be greater than or equal to 0. So if you can say it in English, write it in mathish, solve it, you are done. That's how you do any domain question. So when you solve this, you get at least 8/3. You can make a little interval if you want to. I didn't really ask for it. This is cool. Just leave it like this.
Cool. So on some of them you put question marks.
Yeah.
Some people had an equals here, and then suddenly that became something else. That freaked me out. Some of you guys started here, which is not true. Not necessary because it must be true. It's kind of arbitrarily true. This has to always be positive, so that's not really a valid statement to make. I have to focus on the inside. All right, so some of you guys, your first step was to square both sides. You shouldn't have the square root there anyway. Okay, good. So the most frustrating thing is to get the right answer for somewhat of a wrong reason, and then I take points off, and you're like, dude, the answer was 5. I checked it with this guy over here. Yeah, but you did something wrong on the way. It's not good. So the second one is the other major. Oh, sorry.
Is that because we can't have a square root of 0?
We can totally add the square root of 0. If x was equal to 8/3, I get square root of 0 here, which is 0. I just can't take a square root of a negative number because then I become imaginary.
Oh.
And if I just ask for the domain, it's understood that I'm talking about real numbers, unless I'm more specific. Good. So part B is this guy. So in English, what's the restriction on anything that looks like this? Yeah, so this is fractional, so the bottom can't be 0 in a fraction. So then you just say, okay, bottom can't be 0. That's English. Math is, there's the bottom, cannot equal 0. And then you solve it. How do you solve that?
Factor it.
Got to factor because it's got a higher power than 1.
And find out what would equal 0.
And find out what makes it 0. And throw those out. So be really careful. I had a few people that factored it fine, and then they said their answer was this. Now why would I have a problem with that?
Because that makes it 0.
Yeah, because you're telling me use exactly the thing that freaks it out. Yeah. Johnson, how many can we make? What works? These things, they make everything. No, that's no good. You gotta throw those out. So even if you just do this, I'm actually cool with that. If I'm not specific with how I want the answer, that's fine with me. Right? Or you could even go as far as negative infinity up to negative 11. Oops, negative 8. Or negative 8 up to 11. Or 11 to infinity. So anything in between this and that is fine, as long as you capture that you're throwing out those two options. How are we doing so far? Okay. All right. Okay. So I'm going to kind of keep up this pace through chapter 1. So you desperately have to slow me down. Just chapter 1 is going to go quickly because it's a review section. But please, dear God, definitely slow me down. What I normally say is if I'm going too fast, slow me down. If I'm going too slow, deal with it. All right, so definitely slow me down.
So if I bring in a proof for the bottoms up method, I can use it?
Yep. And I better not be able to find your wording online somewhere. Right? I have to do like an English professor and do the turnitin.com thing or
Oh
something.
no, I'll put it in my own words.
Paraphrase that boy. Well,
According to this.
such as, yeah. Yeah, exactly. If you turn it into a works cited page, it's kind of that might be a problem for me. All right, so let's see. Let's get down to business here. Section 1.1 is chock full of stuff you should definitely, hopefully know. And real quick, why... there's a couple things here that you might not have been exposed to, but one thing I want to talk about real quick is a really simple thing that we just now used, the fact that you can't divide by 0. And what normally does your teacher tell you to say if you get this kind of thing? What's the answer here? Undefined. Anybody heard anything else? Sometimes somebody says it's infinite. Because think about it. What's 6 divided by 1?
6.
Neat. What's 6 divided by 0.1? 60. What's 6 divided by 0.01? 600. So what do you think 6 divided by 0 is? That must be infinity. So that's another way to look at it. We won't look at it like that yet. Later math we'll. This is beautiful for right now because, real quick, just in case you've never seen this. What's 6 divided by 2?
3.
Yeah, that's amazing. Why is 6 divided by 2 3? Be careful. Don't say because 2 goes into 6%. Be more specific.
6
Because 2
times 3
is 6. So 6 divided by 0 has to be a number such that 0 times it is 6. Is there any number defined to do that?
No.
That's where the word undefined came from. All right? So don't take anything at face value. Just say, why do they call it that? If a teacher can't answer it, it's not good. So this is undefined because there's no number defined to do what this says. Cool. Okay. So that's a little side note. The thing that you guys have probably not seen too much, you've seen this symbol
Up to.
today, and what does that mean? Or. So this means or. And I call this the nice bouncer. Right, so if you go to a nice club, and the bouncer at the front, he could be a mean bouncer. He could be this bouncer. This symbol means and. He could say, okay, to get in, you got to have a lot of money, and you got to be good looking, and you got to be dressed nice. All right, well, I got none of those really, so the nice bouncer would be, you got to have a lot of money, or you could be rich, or you can be dressed nice, or you can know the right people, or, so that more and more people can come in with this guy. Less and less can come in here, right? Or if you're looking at financial aid, you look at scholarships. I remember back in my day, we had these giant books before the internets, right? The connection of tubes. So I had to look through this thing, and you look at it and say, you have to be this, okay, that's me, and this, okay, that's me, and this, okay, that's me, and a woman. Oh, okay, all right. So then you go. So they were all and. It kind of sucked. I don't know if anybody's looked for those yet. So how does this work specifically? If I have a set, let me say A is the set 2, 3, 4, and B is the set 4, 5, 7. Yeah, that's exciting. And you've all seen set notation before, hopefully. Sometimes your teachers require you to put answers inside of those little squigglies. Okay, maybe. So what would this be?
4.
No, careful. You're thinking about restrictive bouncer dude. Restrictive bouncer dude would say, not only do you have to be this, you also have to be this. What's the only thing that's both? 4.
So the other one.
And will always be fewer. Or says you could be one of these guys or one of these guys.
2, 3, 5, or 7.
Yeah, look. 2, 3, 4. Don't put 4 again. You already said 4. Good. 5, 7. Sweet. You guys kind of with me? So or says mush everything together. Take everybody. He's the nice bouncer. Right? You could do this or this. And so all these people get in, all these people get in. The mean bouncer, no, you got to be a member of the rich and a member of the well-dressed. And only the fourth dude in the line is. He's the only one that gets in. Okay. All right. Okay. That's bouncer math, by the way. We'll make a whole math course based on that. Blah, blah, blah. Oh, and if I said, here's A is 4, 5, 6, and B is 2, 7, 9. What's that?
No solution.
4, 5, 6, 2, 7.
Careful. And is the evil guy. You got to be both. Is anybody both?
No.
So that is officially this symbol, empty set. So if you make your zeros like that, you have to be very careful. I'm going to see that as empty set, as sort of like no solution. If you mean 0, don't make that symbol. Be really careful for me. Right? That means something very specific. It means no solution. It means empty set. There's nothing that answers what you're asking me. Right? So that is the empty set. Okay. So I thought those were kind of maybe new. Maybe some of you guys have seen that kind of stuff before, but maybe some of us haven't. The inequality stuff you guys have all seen. Absolute value we already talked about. Can somebody tell me? And I got to say this one more time. We're not going to keep this pace up when we get to chapter 2 and so forth, right? So don't go, oh God, this is going to be a horrible semester. Just chapter 1. Can everybody tell me what that is?
Absolute value.
That's beautiful. You could read it. What's the answer? No. Why is it not
Plus or
X?
minus X.
And that you have to be more specific. You wouldn't say the absolute value of 3 is plus or minus 3, would you? Right?
No.
So be a little more specific. It's X if what?
X.
When does the absolute value leave something alone? If the number is already
Positive.
So if X is, or 0, right? And if it's negative, what's the absolute value actually do to it? Makes it positive. And how we mathematically change something's sign, we multiply it by a negative. Students look at that and they say, that's a negative number. No, it's not. I'm saying x is negative, so what's negative negative?
Positive.
Positive. Sweet. So that's why absolute value equations have two cases, because we don't know what the inside number is. I've got to cover my ass for both possibilities. Got it with me? So if I said, what's the absolute value of x minus 7? If x is at least 0, what is it?
Positive.
What would the absolute value do to this? Nothing. I'm sorry, not if x is greater, if x minus 7 is greater than equals. What if x minus 7 is less than 0? What if that's a negative number inside?
Negative x plus 7.
Beautiful. It would change the sign totally. Negative, this would be negative x plus 7. How are we doing so far? Let's test that out real quick. If x is 5, what is this? 2. Well, let's see, what's this then? What's negative 5 plus 7?
Negative 2.
2. Right? So what it says is true. That's what it becomes. It does change the sign. Okay, maybe. So that's why absolute value is a little freaky, because it's got those two possibilities based on what the number is. And if you don't know what the number is, you better do both ways, just in case. Okay, that's why there's two cases. Okay. All right. That's 1-1. 1-2 talks about exponents. We already kind of covered that. We know that negative powers mean flip. I don't feel like talking about scientific notation right now. Hopefully you'll get some of that in the homework. We'll see if you guys have a question about that. It's going to be the teacher. I don't feel like talking about that. 1-3 is all about multiplying polynomials, right? And very quickly, what is it called when you do this? Foil. I have nothing against FOIL really, but it's unfortunate that they taught that in the first place, because FOIL works first, outer, inner, last. Beautiful. So what if I have this? First, outer, first in the middles, and the last in the what is that? That's not FOIL, that's So the idea of FOIL is so much easier if you don't rely on the mnemonic. And it's fine if you do, because everybody probably does. And I say FOIL, so it's in there. But it's so much easier, just that guy distributes, and then this guy gets his turn to distribute. So then it doesn't matter how much stuff I got in there. It's the same idea, no matter what. And then you just put your like terms together. So I don't need a mnemonic device. They didn't need to create one, really. Distribute him, bam, bam. Distribute him, bam, bam. You get your FOIL stuff all together. So 1-3, you guys really should not have any trouble multiplying stuff out. 1-3 is also where they talk about factoring. And do this for me. Let's see if you guys remember what we said earlier. Let me shut up for a second. Do this. It's probably about 10 minutes. Oh yeah, okay. You gonna make it there? Maybe. What is definitely the first step here?
GCF.
Yeah, so you can take out a 2. You can't take out any x's or y's because
Yeah, there's one.
they both don't have x's and y's, right?
Yeah.
So be careful. There's got to be something you can take out of everything. And then this, of course, is a
Cube.
difference of cubes. A of x cubed is 2x, 2x, 2x. Y cubed is y, y, y. So then you can build your little dude, big dude. Don't forget that dude there. He's got to come for the ride. Little dude, big dude.
2x minus y.
Get 2x minus y. 4x squared. Y squared at the end. And then the middle term is going to be
Plus 2xy.
good. Positive, the opposite sign so it can cancel. 2xy. Just product. One of each, two of each, product in the middle. There you go. That's the closest I get to a sign. Okay, so that's cubed. It's normally one of the worst factoring forms for most people. I think the last thing I want to ask you guys, and then I'm hoping tomorrow some of you will come with questions from chapter 1 homework. Yeah,
I already have questions.
you do. Give me 1 second. Let me do one thing and then I'll take your question. This is one of the last things I think we did in 110. And everybody loves this.
How is that in the homework?
Huh?
Is that in the homework?
Oh, well, it's in the sections.
Oh.
1-5. But maybe I didn't capture it all.
No.
It's too good for us that we're doing it right now. So, of course, completing the square deals with what do I put there so that it's factorable like that? Why do you guys remember this? Does it sound familiar? So the 2 steps would be,
Divide B.
good, cut that guy in half,
Square.
and then square it. So then you get, that has to be what makes it work, and that has to be how it factors. That kicks ass. So even if I give you something gross here, like M, yeah, now I could have put fraction there. Let me put a letter there. That normally is really gross for people. Completing a square eats it up, just chomps on it. You just do the steps, and the answers are given to you. So the first step is?
Divided by 2.
Good. What's n divided by 2?
And over 2.
11. So then the second step is? Square it. So then you get? That's what you put there to make it work. That's how you factor it. Done. Just as easy as that one was. Right? So complete square can just munch on anything as long as the first number is a 1. Right? So later we'll look at what if it's not a 1. Get you some nifty stuff. But let me see. What's your question, Ryan?
Oh, gosh. 80 something.
Oh, all the 81 through 84
Yeah.
is awful. The word problems.
Word problems.
All right, let me see. So the last few minutes here, let's focus
81.
on that.
Oh,
Page
125,
126. Oh yeah, all right.
My homework now.
Kick butt.
I know it's a system of equations, but I couldn't remember how to put together.
So is this one we're looking at specifically?
81.
81?
Sure.
Sure, it's the first one. The owner of a store sells raisins for $3.20 a pound. Whenever I read one of these, I just imagine being a student going, the owner of a store, who cares? But you have to care, because you know you're going to get these problems on the test. And they sell nuts for $2.40 a pound. And then they're in the back and they say, let's do something crazy. Let's put those things together. It's to mix the raisins and nuts and sell. So he's going to make a mixture, 50 pounds worth of a mixture, and they're going to sell it at $2.72 a pound.
That was good until they threw that in there.
They have to put that in there. Now, why does it make sense? If I mix these, the mixture's price has got to be
Between
these two.
Yeah.
So if I had equal amounts of both in my mixture, the mixture's price would be halfway, right? So it'd be $2.80. Since it's a little less than that, what did I have more of?
The nuts.
the nuts. I put more of the cheaper thing in there because it's a little less than average. Are you guys, do you actually have to understand anything I just said to do this? No. But it is kind of cool to realize you're kind of diluting the price of the raisins with the cheaper nuts. And you must put more nuts in there than raisins because it's even cheaper than it would have been halfway. You're like, what the hell? So how many raisins, how many pounds of raisins do I use?
X.
Good, I don't know. How many pounds of nuts?
Y.
Good, okay, that's fine.
Use R and N.
Beautiful. Use whatever you want. I would probably use R and N. I was trying to make it relate directly back, but screw it. We got X and Y. So what two equations can I put in? One equation is stupid easy.
R plus N equals 50.
Good. Pounds of that and pounds of that have to make the 50 pounds there. Right? That's straight up enough. And the second equation has to deal with money. So everything's got to be money.
So that'd be 320.
320.
I love it. So I'll get people that give me this. And if you check it, is that how can pounds plus pounds equal dollars? Okay, that's neat. So I know that equation can't be true. I have to have money plus money equals money. So if I have X pounds of raisins at 320 per pound, 320x plus 240 x equals, got it.
No,
Y,
it would
sorry.
be
Equals 272.
272. I like it. Times 50. Beautiful.
That's where I messed up.
So I got price per pound here. So I got to have price per pound times pounds, price per pound times pounds, price per pound times pounds. So now it's price, price, price everywhere. You got to make sure your equation kind of makes sense. It almost feels like chemistry if you ever took the chemistry. Balancing your equation.
Damn, I should have asked you 82.
And now you could just multiply this by negative 2.4 if you want to kill the y's, right? If you want to do elimination. You could solve this for x and plug it in here if you want to do substitution, right? You have a few different ways to approach this. Oh, we got a little bit of time. You guys can see how to finish that out?
Yeah.
You want to do one more of those and then we'll...
82.
Huh?
The running and biking one, whatever that one is.
The running and biking?
Oh, that's 83.
83? Let's look at 83 real quick and then we'll head out. So a woman cycles 8 miles an hour faster than she runs. Okay. Every morning she cycles 4 miles and runs 2.5 miles for a total of 1 hour. Blah, 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 blah. So what you do to kind of help yourself keep track of all this stuff is definitely two separate kind of things going on. She's got biking and running, right? What can I fill into the bike there? What's the equation that kind of governs what's going on in this problem?
Rate times time equals distance.
Yeah, dirt, right? Distance equals the rate times time. And really the chart is really just an organizational thing. It's just to help us organize what goes where. Plus I got the equation to help me figure out what goes in the blank spots. So what can I definitely put down here?
The distances.
She cycles 4 miles, good.
2.5.
So she bikes 4 miles and runs 2.5.
And then the rate.
She cycles 8 miles an hour faster than she runs. So which one's just X?
Run.
Runs. So biking would be
X plus 8.
so saying I love it. Right. Now what about the time?
It's an hour total.
Blah, 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 blah. A total of 1 hour of exercise. So where I get the big mistake is people put a 1 and a 1 there or something. Well then that's 2 hours. So then they put a 0.5. How do you know she cut it in half? I don't know. So what you do, the minute you get one blank spot, you know exactly what goes there. If distance is rate times time, time is
Distance divided
distance divided by r. Just divide by r to solve for t, right? You guys with me? So then how do I get this time? I take the distance
4 divided
by the rate. Right? So I get 4 over x plus 8. Distance divided by rate, 2.5 over x. And these two are supposed to do what?
Add
Add together to
Good.
equal.
The total time is 1. So you get 4 over x plus 8 plus 2.5 over x equals 1. It looks a lot like that first problem on the warm-up exercises we did. Right? LCD kind of stuff goes on here.
Alright.
I put them to equal each other. That's where I messed up.
Oh, okay, no. If they would say you had the same amount of time, that would have been the way. All right, guys. So I'll post the video right now. Huh?
Factory sheet.
Oh, the factory sheet. Yes. Let's see if I can remember that by the time I get to my office. I don't have high hopes for that. We'll see.